Unit 6, Lesson 3 and 4 homework. Here's a table and scatter plots that compare points per game to free throw attempts for a basketball team during a tournament. Question A says, circle the point that represents the data for player E. Well, if we go to player E, it's highlighted here. It tells us he attempted 3 1/10 free throws at 10 4/10 points. So 3 1/10 to 10 4/10 would put this point, so we circle it and label it E. Question B says, what does this point represent? This point represents that player E had 3 1/10 free throw attempts and scored an average of 10 4/10 points per game during this tournament. Question C says, in that same tournament, player O on the other team scored 14 3/10 points per game with 4 8/10 free throw attempts per game. It says plot a point on the graph that shows this information. I added the information to the bottom of my graph, highlighted it, and then graphed my point at 4 8/10, which is almost 5, and at 14 3/10, which is close to 15 on my graph. Question 2. The scatter plot shows the number of hits and home runs for 20 baseball players who had at least 10 hits last season. The table shows the values for these 15 players. It gives the model equation of y equals 1500 x minus 1 5/10 and is graphed with a scatter plot. If you notice, A says player A had 154 hits in 2015. How many home runs did he have? Well, I highlighted player A and labeled him. He had 26 home runs. He was only predicted to have 21 6/10. So his point will be above the line, prediction line. And if you notice, we come over here to 150 plus hits and go to player A who had 26 home runs, and we circle and label. So player A had 26 home runs, but was only predicted to have 21 6/10 for that season. Question B says, player B was the player who most outperformed the prediction. How many hits did player B have last season? Well, player B is the only person or the only player that more than doubled the predicted amount of home runs with his hits. So player B had 57 hits and 16 home runs, although he was only expected to have 7 1/10 home runs. So player B had 57 hits last season, 16 home runs, surpassing the prediction of 7 1/10 home runs. What would you expect to see in the graph for a player who hit many fewer home runs than the model predicted? Well, I would expect that point to be much lower than the prediction line on our graph. Before we move on to another question, let's notice that player B with 57 hits and 16 home runs was well above our predicted line, as we said he would be. Question 3. Here's a scatter plot that compares points per game to free throws attempts per game for basketball players in a tournament. The model represented by y equals 4 413 thousandths x plus 377 thousandths is graphed with the scatter plot. Here x represents free throw attempts per game and y represents points per game. Circle any data point that appears to be outlier. Well, if you notice, this point falls farther away from the prediction line than any of the other points. Therefore, that would be our outlier. So that was the answer for question A. Question B says, what does it mean for a point to be far above the line in this situation? Well, a point far above the line represents a player who scores more points per game than predicted for their number of free throw attempts. Because our graph is based on points per game per free throw attempt. Remember, we read the vertical axis for the because it's the dependent in this case to our independent variable, which is our free throw attempts. Question C. Based on the model, how many points per game would you expect a player who attempted 4.5 free throws per game to have? Round your answer to the nearest tenth of a point per game. If you notice, I went back to the equation. In that equation, I put the free throw attempts, 4.5 free throw attempts, into my equation, and I solved it, or evaluated, and found that its prediction is 20 2/10 points per game for that player. In question D, we are also going to use the equation that was given for our prediction line for the player, a player who scored 13 7/10 points per game with 4 1/10 free throw attempts per game. We wanted to compare how the model predicted to the actual. Well, we know the player actually scored 13 7/10 points and have an average of 4 1/10 free throw attempts per game. So we evaluate or substitute the equation using 4 1/10 attempts to get a predicted point value of 18 5/10 points per game. This person, however, only actually scored an average of 13 7/10 points per game. So that person would definitely be below our prediction line. I hope you did this well.